Welcome to the Walton Pi. Let's go through some examples of exponential growth and decay. Alright, to get started, let's look at the half-life of Einsteinium. So half-life of Einsteinium, this is 20.5 days. So what we might be asked to do is be given something like, if we start with 100 grams of Einsteinium, which is a little bit unreasonable, but it's a nicer number than some others. So if we start with 100 grams of Einsteinium, find a function that describes how much Einsteinium we have. At any given time. At a time t, which is measured in days. So how might we approach this problem? Well, one way we could do it is we could say that we know that, let's say that we say f of t is the amount that we have. Well, every 20.5 days, we're going to have half as much as we did. So what we could do is we could say this is a 1/2 raised to something, but then we have to multiply it by how much we started with. Well, we started with 100 grams. So what is it going to be 1/2 raised to? Well, every 20.5 days, it needs to be halved. So we are going to do a t divided by 20.5. So that means after 20.5 days, we will have half as much as we did. After 41 days, we will have 1/4 as much as we did. And so this is our function that's going to describe how much Einsteinium we would have at any given time. So then if we were to ask, how much would I have after 100 days? You would be able to plug this in and be able to solve it. Now, on the other side of half-life is the doubling time. So this is a little bit timely, but at the same time unfortunate. We might say that we have some disease. Maybe this is caused by some bacteria. So this doubles in population. And let's say it's going to be doubling every 13 hours. What is our population function? How would we find that? Well, this is the same sort of thing as we would have with our exponential growth and decay sort of problems. We would say we have some population, so population in terms of time. Oh, we needed some starting amount. Population function, and we know that at t equals 0, there are 100 bacteria. Well, the population is going to be, how much do we start with? 100, but then we multiply this by 2. But how often do we multiply it by 2? Well, it's every t hours once we've divided it by 13. So that every 13 hours, it'll double once. And this is going to be what our population function would be. I hope this video was helpful in being able to see a couple more examples of doing stuff with exponential growth and decay. If you're not already, please consider subscribing because it really does help me be able to make more of these videos. And please check out some of my other videos that I've made on all sorts of different topics involving calculus. I hope you all have a great rest of your day, and good luck with the rest of your math.